Welcome to Chemistry with Crip. We begin with reviewing takeaways from the atomic interactions simulation that we previously discussed. Note that when there are no interactions at all between two particles, or in this case, two atoms, when there is neither attraction nor repulsion present, potential energy for the system will be zero. However, when the atoms have been pressed against each other to the extreme, enormous repulsions will be generated as like charges overlap each other, and potential energy will be greatest or most positive. Furthermore, when atoms are placed at the appropriate distance from each other, stable attractions between the unlike charges in each atom can dominate, and the potential energy for this system will be at its lowest. This attraction is the basis of a stable chemical bond. When comparing bonds with each other, we realize that some bonds will be stronger and more attracted to each other than others. The first example shows a weak chemical bond. The bond has a weak attraction, and thus a relatively small negative value for its potential energy. The second example is evidently a stronger chemical bond and has a relatively larger negative value for its potential energy. In a chemical reaction, the attractions between atoms become rearranged, with old attractions becoming broken and new attractions forming. Breaking old attractions always requires energy, and forming new attractions must always release energy. If a process goes from having stronger attractions to having weaker attractions, more energy has come into the system than has been released, and the process is called endothermic. Endo meaning in, and therm meaning heat energy. If a process, however, goes from having weaker attractions to having stronger attractions, more energy has gone out of the system than has come into it, and the process is called exothermic. Exo meaning out, and therm again referring to heat energy. In an endothermic process, the potential energy of the system always increases. As such, attractions have been weakened, and overall, the system has absorbed energy. Therefore, the change in energy for the system is positive. In an exothermic process, however, the potential energy of the system always decreases. As such, attractions have been strengthened, and overall, the system has released energy. Therefore, the change in energy for the system is negative. Till next time, we discuss the mysteries of the absolute